In this class, we'll be looking at complex numbers. Now, what are complex numbers? A complex number x, or a number x, is said to be a complex number in the form of x is equals to what? A plus what? IB. Is this complex number. So when we have any number in the form of what? X equals what? A plus IB, where we have our A and B to be what? Real numbers, and we have our I squared to be equals to what? Minus 1, which implies that what? It implies that my I is equals to square root of what? Minus 1. This is what complex numbers. Now, in this case then also, my A here represents my what? Real part, of the complex number. My B represents what? The imaginary part. Imaginary what? Parts of my complex numbers. Now, under this, what do we look at? I'm now going to look at the algebra of complex numbers. Algebra of what? Complex numbers. Now, before complex numbers, we have other numbers under it. It means complex numbers is like the universal set of real numbers, natural numbers, integers, rational numbers, and the likes like that. So you get two. Now, under algebra of complex numbers, what are we going to have? For the first one we're going to look at here is equality of complex numbers. Equality of complex numbers. Now, given that x equals what? A plus IB, and y equals what? C plus what? ID. X is said to be equals to y if and only if A is equals to C and what? B equals to D. What do we mean? When the real part equals themselves and when the imaginary parts equals themselves. Okay, that's for this. Now, in the next class, we'll be looking at addition, subtraction, multiplication, and division of complex numbers. Then we'll be looking at the conjugate of complex numbers also.